Wondering if your device supports the Mixed Reality Toolkit? Well, I have great news. The Mixed Reality Toolkit has cross-platform support. So what that means is that you're pretty flexible with regards to which device you could actually use. Now, beyond the HoloLens and the HoloLens 2, you can deploy projects that make use of the Mixed Reality Toolkit to a variety of devices, which include the HTC Vive, Oculus Rift, Oculus Quest, Android and iOS devices, as well as the Leap Motion by Ultraleap.
Hi, I'm David, founder and CEO at MindPod. In this session, we're going to share how we are democratizing VR content creation. We are Marcella, Niklas, and myself. MindPod is located in Siegen in the west of Germany, but since we are a remote-only company, everyone can work from wherever they like. I'm actually the only one living in Siegen. Marcello is living and working from Munich in the south of Germany, and Niklas is even in Mexico right now. Let's take a look at the agenda. Before talking about how we are democratizing VR content creation, we first would like to share why we are doing it. Then in the main part, we are talking about challenges we encounter in our mission and how we tackle them. Finally, we are wrapping things up and providing you with helpful information how to contact us and how you can join our cause. So, since democratizing immersive experience is not very tangible, we would like to make this more explicit by giving you an example. Here you can see two wounds of different burns. And as you might be able to imagine, those wounds have to be treated for a long period of time, and this is very painful. And this is especially hard if the patients are children. And in 2003, the HIT lab have studied the effect of virtual reality on the perceived pain. And here you can see the setup. So a person is lying on the bed and can immerse themselves in a virtual world. And the virtual world you can see on the left, it's an ice world. And there they can throw snowballs at snowmen, penguins, and woolly mammoths. And the effect of this is significant. So here you can see on the left side, people or in the control group were just distracted by playing Nintendo, and the pain that they reported in regards of intensity, unpleasantness, and time thinking about it is extremely high. They feel anxious and not very present. In comparison, on the right side, you can see how they felt in the VR experience. So the pain was decreased in all three parameters significantly. Anxiety was gone basically, and the presence was very high. If you'd like to learn more, on the bottom you can see the source. So when I first heard about this, and this study was done 18 years ago, I was thinking, why are there so few applications right now? And it cannot be the hardware, it's broadly available and cheap, but what still is hard is the creation of VR software. And the reason for that is you need dedicated virtual reality specialists who can develop the solution on the one hand side. And on the other hand side, you need subject matter experts who know the problem and why VR can address this. And in the above mentioned example, those researchers had to have the knowledge about the field, so knowing pain is a problem, having the understanding that a cold, immersive environment would help in this scenario, and they had the competencies to create this application. And people with both those skills are very sparse. And what we are trying to achieve here is bringing those two skills closer together, that more people can create such content. And our final goal ultimately is that those completely overlap, that everyone can do it. And this is what we mean with our mission to democratize immersive experiences. And on this mission, we encountered several problems, and we are going to share the two main of them. And the first one is the accessibility of this creation. So as we just talked about, bringing those subject matter experts closer into this creation process. And the tricky part here is that we have very different needs on those persona groups. So the VR developers, they require flexibility, they like to solve problems on their own, they prefer written technical documentation, and they can fix broken things, especially if they're working with game engines. On the other hand side, subject matter experts, they require an easy-to-use interface. They don't want and often can't write code. They prefer non-technical documentation, and they usually cannot fix broken things. And this is hard to balance because it's very different requirements. And what we are doing here, VR Builder is trying to do that. And we are doing this because the VR Builder is a powerful, flexible, well-documented open source software based on Unity, which makes it possible for VR developers to do everything they are used to do in Unity and use our open APIs and the open source community to build whatever they want and need. And on the other hand side, the subject matter experts, they can use a robust, easy to use and graphical user interface to get into the creation of that. So, and we would like to give you an example of that. And for this, we are using an actual real-world use case. One of our clients had to train several people for the logistics center because they changed the processes. They introduced an SAP process, which means the employees there had to learn new procedures, which included confirming what they are doing in the SAP system while they're doing it. And this was standardized, so they had to do it in a exact order. Without VR, they would have to train with paper-based material, which usually doesn't have a good effect on the learning experience, or they could use the actual logistics center and lose lots of revenue. So virtual reality was a good use case for that. And now you can estimate, and please write in the chat, how long you would estimate this took, or also what you could do is estimate how much such an application would cost if you would contract someone. So we'll give you a few minutes, think about it, and just write it in the chat. And we are now doing a simplified version of exactly that use case, which just includes 3 steps. You have to grab a box from a shelf, put it on a conveyor belt, and then confirm this by pressing a single button. So what we're doing here, it's the same requirements, but just in a very slim form. And so it's for this demonstration, it shows you the real-world application that's behind it, but it can also be shown now in a few minutes. And this will be done by our marketeer, Niklas.
Thank you, David, for this nice introduction. And hi everyone, I'm Nick, and I'm responsible for the marketing activities here at Mindport. I'm excited to give you the product demonstration today for VR Builder. And as some of you might imagine, I as a marketeer, I don't have so much coding experience. But I think this shows even better how easy it really is to use VR Builder, even though you're not a developer or have limited coding experience. So in today's product demo, we're gonna cover on how to configure and set up the scene with VR Builder. Then we're gonna create the different steps of our training application. And finally, we're gonna watch on what it looks like in VR. So here you have the open Unity project. And this simple scene was created with a conveyor belt that we designed using Blender, and then we imported it into this Unity project. The storage rack with boxes here and the sample scene both are free assets from the Unity asset store. And we've chosen them because both have a low polygon count, and this improves the experience for the user in VR. So in order to configure the scene with VR Builder, we're gonna go here to Tools, then VR Builder, and select Create New Course. The setup wizard here helps you to configure the Unity scene within just a few clicks. So in step 1, we're gonna select the name for our training application. Because in today's example, we're gonna create a logistics training application, I'm just gonna leave it with my logistics course. So in step 2, we're gonna select the VR hardware. I'm using a Samsung Odyssey, which is a Windows mixed reality device. So I'm just gonna check the tick box here and click Next. In step 3 of the setup wizard, we find an overview of helpful resources. So here are different links to documentation and tutorials to help you get started easily with VR Builder. We can then click Finish. Okay, here on the bottom, we have the workflow editor of the VR Builder training engine. And this we're gonna need to create the different steps of our training application. And this we can do by a simple drag and drop behavior. So in order to create the first step, we're just gonna right click and then select Add Step. Here the the step inspector. This we're gonna need to create the different behaviors and conditions later on for our training application. And for now, I'm just gonna drag and drop it here to the right. So now in the first step, we want to welcome the VR user. So once the user enters our training application in VR, he or she hears a voice hearing welcome. So for this, we need to use a text-to-speech engine. And text-to-speech engine are powerful tools to guide the user intuitively in VR. This, for instance, can be easily done with text, because text normally is either too close or too far away from the user, and thus provides rather uncomfortable experience. But text-to-speech engine can be here a powerful alternative. Then step 2, we want the user to grab the box. So again, we need to instruct the user with, when using a text-to-speech engine to please grab the medium-sized box with the blue belt. And then we want to make the box grabbable and check if it was grabbed. So for this, we need a grab object condition. And for here, I'm just gonna go over to transitions. And then I'm just gonna, drag and drop this box item into this box and press fix it. So now everything is set up automatically in VR. As a third step, we want the user to put the box on the conveyor belt. So again, we have to instruct the user with a text-to-speech engine, so that once the user enters the step, here's now put the box on the conveyor belt. Then we want the user to place an object, or in this case, the box, into a predefined area. And for this, we need a snap object condition. And this snap object condition is super powerful because first off, it checks if the object is in the right place. Then it pulls the object into the right target position. And also it provides a visual highlight, which is also called the snap zone. And this snap zone can be just created with one click. So the snap zone also uses the same geometrical model as the actual box. So we've just created the snap zone for the box. And we can also modify the position and orientation of the snap zone. I'm just gonna modify a little bit the rotation. And that looks great. Beautiful. So now in VR, if the person is close enough or moves the object close enough to the snap zone, it will show a visual highlight to the user. And on release, the box will then snap to the right target position. In step 4, we want the user to touch the red button. So in order for the box to move along the conveyor belt into the target position. So for this, we again want to instruct the user with a text-to-speech engine. So to then press the red button on the left. And now we need to make the object touchable. So for this, again, we need a touch object condition. And yeah, for this, we just drag and drop or reference the button and press fix it. So yeah, this now tracks if the controller or the hand is in the collider of the red button. And yeah, now the red button is made touchable. In step 5, the box is moved as a result of touching the button. And in order for the object to move or the box to move along the conveyor belt, we need a move object behavior. And yeah, this behavior is automatically triggered when the step is entered and after the red button is touched. So again, here we reference the box and press fix it. So now the final position provider is the dispatch area. And this is just a transform object with geometric information. And so the box will move into the spot here. And finally, we want also the user, once he or she has successfully completed the training, to have a visual element that tells him or her that, now everything's over and finished. So I'm going to use confetti in this case. And for this, we just need to go to behaviors, select VR Builder, and spawn confetti. So now when the user in VR has successfully completed the training application, there's going to be confetti raining from the top. So that's everything now. And yeah, let's have a look what it looks like in VR. So for this, we have to press play. And let's try it out. So I'm now grabbing the box. Then I'm moving the box into the snap zone. So now it provides, snap zone now provides a visual highlight indicating if the object is in the right spot. And on release, it snaps to the right position. Then I'm gonna press the red button on the left. And the box is moved along the conveyor belt to the target position. And voila! Success! Confetti is raining from the top, and we now know that we successfully completed the logistics training. So I really hope that I could show you the ease of use and powerful features of VR Builder. And let's go back to David.
Thank you, Nick, for this great demonstration. Now that we have seen how VR Builder helps non-developers, let's take a look how it helps developers as well. We created VR Builder with extensibility and flexibility in mind. You can just write your own custom scripts, and by implementing our interfaces, your functionality will get available on the graphical user interface, so that non-developers can use them directly. In case you need even more flexibility, you can go to GitHub. You can make changes in the open source code and do pull requests, so that those will be reflected in an upcoming release. In case you have any further questions, a comprehensive documentation and an active community will help you answer them. In the next live demo, Marcello will show how a developer can extend VR Builder. He will do so by creating a new custom behavior. Have fun!
Hello, I'm Marcello, developer at Mindport, and I'm about to show you how VR Builder works under the hood and how you can extend it to suit your own needs. For this, I've prepared a Unity project where I downloaded the Unity Asset Store version of VR Builder and prepared a process scene where I added a couple elements, a ground plane, and I built a propeller with basic Unity primitives. So this is an empty game object with some spheres and cubes parented to it. My idea is I want to create a process where the user touches this propeller and it starts spinning. It's pretty easy to do the touching part because there is a touch condition in VR Builder already, so we can just use that. There's nothing that allows us to spin the propeller though, so we will have to write that behavior from scratch. Let's see how it's done. First, we can add our first step in the workflow editor, and this is the step where we touch the propeller. So we go to transitions and we will add a condition to the only transition in the thing. And it is a touch object condition. We want to touch the propeller. And we already know that by pushing the Fix It button, the propeller will be configured to work in VR Builder. But let's look a little more in detail to what that Fix It button did. Now we see this was an empty game object, and now it's not anymore. There have been some components added to it. Notably, now there is a training scene object component that is how VR Builder identifies game objects in the scene. In case we need something more than just a reference to the game object, we can add properties. In this case, a touchable property has been automatically added to the game object, and the touchable property knows if the object has been touched. This in particular monitors the interactable object, which is what makes the object grabbable and interactable, touchable, and so on in VR. And but other touchable properties can be implemented, or other properties in general, to manipulate other parameters. Now we settled the touch step. We want to create a new step, and this is the step where the propeller will start spinning. Let's call it spin, and we want to add a behavior here, but a behavior that does what we want doesn't exist yet. So let's create it. Let's add a script to the script folder, and then I will open it and let's have a look at it in Visual Studio. Here we are. This is basically an empty behavior script at the moment. Every entity in VR Builder, be it a behavior or a condition, implements these two classes. This entity data class is a data class where you insert the properties you need for your behavior or condition to work, and this activating process where the actual logic is. We will look at that later. For now, let's add the properties. Now I added, we have these two properties were already there because they are used by every behavior, and so they're there by default. And then I added these extra 4 properties that we need for our actual spinning behavior. These are set as data members, so they are serializable, and they are a scene object reference, which is a reference to that training scene object component we saw before. And this could be, if we wanted a reference to an object with a specific property, we could reference directly the property. For example, an iTouchable property if we wanted to do something with touch or so on. In this case, we are manipulating the transform, so we are just happy with the game object reference. Then I have a vector 3 for the rotation axis, a float for the duration in seconds, and a float for the rotation speed. After we did that, we need to add a couple constructors to our behavior. And these are an empty constructor that every behavior and condition needs to have in order to work with VR Builder, passing some default parameters, and a standard constructor which passes all the needed parameters. Then we can start writing the actual logic for the behavior. Here it is done in this activating process class, and you can see a few methods that are overridden in there. There is start and an update method, which sound familiar, and it should be because they work exactly the same as the start and update methods from Unity. So this is executed when the behavior starts, and this is executed every frame until the behavior ends. So for something spinning, we probably want to put our code here. Okay, and this is some basic code that until the duration has passed rotates the object around an axis. And yeah, that's it. I spend a word on these other two methods. The end method is called when the behavior ends its activation, and it's useful in case you want to set a state at the end of the behavior. For example, if you're moving an object from point A to point B, you want it to be at point B at the end of the behavior. If you set it at point B here, after the animation, let's say, you're sure it will be there even if you fast forward the behavior, meaning you skip it and just get at the end. Then it will replicate the state at the end of the behavior. And the fast forward method is used for things that need to be executed when fast forwarding. We don't need to bother with any of this for our particular behavior because we are not changing the state, you're just animating something for some time. We don't really care which position it is when it ends and so on. So now this behavior should work fine. The problem is we won't see it in VR Builder yet. That's because we need to create a menu item for it. So let's go back into Unity and let's create a new script. Let's have a look at this menu item script. And this simply overrides a class and allows you to set the display name this object will have in the menu. In this case, I called it spin behavior and put it in a custom category. And then this getNewItem method needs to return a default instance of the behavior. Then with this done, everything should work in Unity. So let's get back to Unity and let's finish configure our process. I add a behavior here. I apologize, you're not seeing the menu. That's because I'm recording Windows, but I'm basically clicking on category custom and clicking on spin behavior, and now we have this. Now I can drag the propeller as the target object, and it won't bother me with a warning or fixed thing because the propeller already has a scene object component, so it's already set to work here. Then we need to decide which axis it needs to spin on. It's the Z axis, so let's make 0, 0, 1, actually -1, so it spins clockwise. Let's make it spin for 5 seconds. Let's make it spin at 180 degrees per second. And now this should work. Let's try it in VR. Okay, and now I'm here and I can see the propeller in front of me, and now I'll just touch it and it starts spinning. So it's all working as intended. This was a very simple demonstration, but I hope it helped you understand how easy it is to adapt VR Builder and extend it to suit your needs. That said, I thank you for your attention, and I will give the word back to David.
Thanks, Marcello. This was great. Now we have seen how VR Builder addresses the needs of both the developers, represented by Marcello, as well as the non-developers, represented by Niklas. Let's take a look at our second challenge. We encountered so many problems when creating VR content. And to give you a glimpse, you will have to figure out how to support different hardware, how to get assets for VR, how to avoid motion sickness, how to guide people in VR, how to provide haptic feedback, and many, many more things. And we understand that we cannot solve them alone. So what we want to do is we want to create a synergetic ecosystem, which consists of our open source product, an active community, and partnerships. And everything is based on openness, honesty, and fairness. We already have found 4 partners who share those values with us. The first one is Unity. You probably know them. They are the leading game engine for VR creation, and what we really love about it is the great support for 3D assets. So you can either use the 3D modeling tool and import your assets. You can also get them on the asset store, or in case you have CAD data, you can convert them via pipelines like Pixies. Interhaptics is a specialist for hand tracking and haptics, and we will go into details how they are integrated with us in the next slide. Interactive provides a solution for managing and deploying content. And they also feature render streaming. This is great because it allows you to run high-quality applications on cheap hardware. LevX are experts for training applications in both single and multi-user scenarios. We recently developed an integration with Interhaptics. And what you now can do is the following. You can start with Unity, get your 3D assets ready. By using VR Builder, you can make the scene and everything ready for VR. If you utilize now this integration with Interhaptics, you can not only use hand tracking, but also add haptics. So if you use hardware from Sensorics or SenseGlove, for instance, you can not only grab things in VR and move them around, you can actually feel them in your hand. So this creates a higher immersion, and by this, a better experience. After that, you can also talk to LevX and ask for help to get your applications ready for multi-user, and you can then deploy everything via an interactive portal and deploy it around the globe. So what we have here is not just a list of partners, it's an integrated and living ecosystem. And in case you too have something valuable to add here, please join forces and apply at partner.mindpod.co. Let's wrap things up. We started with our mission and explained what we mean by democratizing immersive experiences. We gave you an example of treating pain in VR, and we want to help more people create such great content. Then we talked about the 2 major problems on our mission, and the first one is the contrary needs of our user groups. We gave you 2 live demonstrations of how VR Builder helps those groups. The second problem is that there are so many problems when creating VR content, and we tackle this by creating a living and growing synergetic ecosystem. Of course, we are not done yet. We want to get more partners into integrations to grow the ecosystem. We would also like to provide a collection of VR-ready assets for you so that VR content creation gets even faster and easier. And we would like to add more features for VR Builder, and in case you have any ideas or any needs, please let us know. Here are some direct links for you for your convenience. So first, please try the product. It's free, it's open source, and if you like it, please share it with your colleagues and friends. If you have any questions, please join our community. You can get help, provide feedback, and share ideas. And lastly, if you have a compatible offer, please apply to join the ecosystem. Let's start the discussion. We are happy to answer all your questions.
Hi, David. How are you?
Hi, I'm fine, thanks. How are you?
That's great. That's great. Thank you so much for this, for your presentation. And I just wanted to know if you had anything else that you wanted to add to this.
No, but maybe again. So I hope we made clear why we are doing what we are doing and also how we are approaching things. And if you want to join, please do so. So if you are a creator yourself, please try out our tool. If you are a potential partner, please reach out to us. And in case you have any questions or ideas, please just join the community and let us know what you think.
Great. Okay. Again, thank you so much for taking part in XR Global. And I know that these will continue to live out there for people to find you. My favorite part was when you said it was open source. So I will be going to check it out and to get other people involved with this, because today is just so exciting. And I really hope that we can all bring this forward. So thank you again, David, and thank you from XR Global. And thank you, everybody who's watching.
Thank you, and thanks for having us.